Okay, in this video we're going to be talking about cylinders, so kind of what looks like pop cans. Okay, so cylinder has two congruent parallel circular bases, so you're going to be seeing a lot of pi r squareds for area of its base. The altitude is a perpendicular segment that joins the planes of the bases. The height of the cylinder is the length of the altitude. So my picture accidentally copy and pasted in the words. It was supposed to say length of the altitude. Okay, so the height is going to be what connects your two circles together. So lateral area is going to be 2 pi times the radius, because that's going to be the kind of like the perimeter, because this stands for circumference. So instead of doing perimeter, we're doing circumference, still times that height. Okay, so it's like the same thing, perimeter times the height, except for this time, our perimeter for circles is circumference, so 2 pi r. Okay, our surface area is going to be that lateral area, plus, since we now have two circles again, 2 area of a circle is pi r squared, so that's why we have our pi r squared there. So you can either write lateral area plus 2 pi r squared, or lateral area is the exact same thing as 2 pi r h, so you'd have the full equation to just plug and chug if you wanted to. Okay, so your first example would be on your chart again. I'm going to show you how to do lateral area and then add the area of the bases to it, and then we can just plug and chug straight from the equation from here on out if we really want to. Okay, so lateral area is 2 pi r h, so my radius we need, my height we need. So my radius all the way across is 6, so my radius is 3. My height that connects my two circles is 1. So 2 pi times radius times height. So we're going to get 6 pi inches squared. Then I take my 6 pi and I add 2 pi r squared for the area of its circle. So 2 pi times my radius was 3, so 3 squared. So 6 pi plus 18 pi. So 24 pi inches squared. Okay, so we're going to do one more of just doing it separate again. So my radius is 4.5, my height is 8.5. So 2 pi radius height. And I'm going to run out of space for that. Okay, so that gets me 76.5 pi centimeters squared. So my surface area then is 76.5 plus 2 pi, my radius squared, so 4.5 squared. And that's going to get me 117 pi centimeters squared when I type it all in. Type it in without the pi's, and then just make sure your answer has a pi attached to it. Okay, if I plug straight into my surface area equation, so first my radius is 8.5, my height is 7. So my surface area equation, if I plug and chug straight from that one, it is going to be 2 pi times the radius times the, make that 8.5, times the height plus 2 pi, the radius again, squared. So you can type it all in at once if you're just going straight to surface area. Okay, and for this we are getting 263.5 pi meters squared. Okay, my next one, if I plugged it in again, so radius is 2, height is 10. So if I went straight to it, I got 2 pi times my radius times my height plus 2 pi times my radius squared. I would get 48 pi millimeters squared. Okay, volume is area of the base times the height. Well, since my base is a circle, area of its base is pi r squared times its height again. Okay, so we're finding the lateral area, surface area, and volume. So lateral area, surface area, volume. So my radius is 3, my height is 5. So 2, oh come on, pi times my radius times my height. So 30 pi centimeters squared. Okay, surface area is that 30 pi plus 2 pi radius squared. So 48 pi centimeters squared. And this is area of the base times the height. So pi r squared times my height that connects them. So 45 pi centimeters. Remember, volume is cubed. Okay, this one should be on your chart then. So your radius is 3, your height is 1. So V equals pi r squared times the height. So we get 9 pi inches cubed. Radius is 4.5, height is 8.5. So V equals pi r squared times the height of 8.5. So V equals 172.1 pi centimeters cubed. R equals 8.5, H equals 7, so V equals pi times 8.5 squared times 7. So 505.8 pi meters cubed. R equals 2, H equals 10, so V equals pi times 2 squared times 10. So 40 pi millimeters cubed. Okay, the last thing to talk about is composite figures, which we did in the last lesson. A composite figure is a 3D figure that has a combination of 2 or more solids. So it's if I take 2 or more 3D figures and I stick them on top of each other. Okay, you can find the total volume by finding the volume of the 2 and combining them. To find the total surface area, you just have to make sure you do not include the surface that is connected. Total surface area means everything on the outside, not what's on the inside. So that's what's tricky about the surface area. Okay, so finding the surface area, it looks like we have a cylinder and then we also have a prism. So let's go ahead and do the cylinder first. So the cylinder, the surface area, I need the radius. So all the way across it looks like is 4, so my radius is 2. My height that connects my 2 circles is this 3. So it's 2 pi times radius times height plus pi r squared. So that's going to get me 20 pi meters squared. So that was cylinder. Now we've got to do the prism. But with this prism, I don't want to include this face and this face because it's on the inside. So I'm going to have to do it all by hand. So if I do the area of this top one first, I've got a 4, and I know this is also 6, so 4 times 6. Plus, if I want to do this front face here, so this one, I've got a 3 times 6. And I know that's going to match this back side, so I'm going to just do 2 of them. And then that top that I already did, that 4 times 6, right here, is going to match that bottom. So I'm going to times him by 2 as well, because there's 2 of them. So my total is going to be 84 meters squared. And to add these, to get my total surface, you actually have to type the pi button in this time. So 20 pi. The reason you have to do that is because my 84 doesn't have a pi attached to it, so they're not in common terms. So you have to actually type it in and get 146.8 meters squared.